All right, welcome back. Greetings to you, pre-calculus. Pre-calculus part 3, 1.1. This first section is just keeps going. I've only got 3 examples left over, and they're all application-based problems. A couple science, and I don't know what the last one is. They might all be science. Let's just dig into it. So number 55, we're talking light years. 1 light year is the distance a ray of light travels in 1 year. If the speed of light is approximately 186 miles per second, estimate the number of miles in 1 light year. So we could just Google this and figure it out right away. But that's not fun. Let's work this out. Now the thing that jumped out at me right away was it said number of miles. And miles is a distance. And in science, we have this formula that relates distance to miles per second. That's a rate. That's a speed. It's a rate of change. Distance equals the rate of change times how much time it's doing its changing. So they're kind of expecting us in pre-calculus to, every once in a while, reach out and grab like a formula from physical science. So make sure you keep those, right on the tip of your brain. Don't just shove them in the back corner and store them away for only science class. So distance equals the rate of 186 miles, 186,000 miles per second. I'm going to keep the units on here. Times, the time is, well, what's going on here? It's the number of miles in 1 light year. 1 year. So here's the thing. Distance must be miles. And right now, we've got a unit called miles year per second. That seems to me to be a bit problematic. So what we have to use is this thing called dimensional analysis, where we take year and we convert it into a unit that's actually going to cross-cancel with the seconds on the bottom part of this rate fraction. So let's do it. All right, so 1 year has how many seconds in it? I gotta go backwards a little bit. One year, let's just start with 365 days. Now, let's just forget about leap years and all that stuff. Now, the days now needs to cross-cancel down here. So the idea is, what's the next unit that makes sense to work with? What do we know about days? Well, there's 24 hours in a day. So it would be wise to compare hours with days. So now we've gotten rid of days. And so now we multiply that by, let's see, hours. There's 60 minutes in an hour. So the hours unit is gone. And then we multiply that by 60 seconds per 1 minute. Per 1 minute. Got it. So now we've got 365 times 24 times 60 times 60 seconds per 1 year. So now we can just straight up replace year with, okay, maybe we need to calculate this. So 365 times 24 times 60 times 60 is a really large number. Looks like 31,536,000 seconds per year. So it cancels the seconds degree. And here's the thing. Earlier in this assignment, we had scientific notation. And it makes sense to me like, oh, Here's a good way to review that without just doing a basic scientific notation problem. I'm so sorry. You guys didn't see this part. I apologize. But look, that's all I did. I calculated it up here and then I put it on the whiteboard. We okay? Good? Yes. All right. So now that we've got this massive calculation to take care of, let's think about scientific notation. Scientific notation says, let's create a better way of talking about a number without all the zeros at the end and all the crazy amount of digits attached to it. So scientific notation says 186,000 is equivalent to 1, 2, 3, 4, 5 powers of 10. It's 1.86 times 10 to the 5th power. Because you basically multiply that by 10,000 and you've got 186,000. So then we're taking that number and we're multiplying by, if we go over here, 1, 2, 3, 4, 5, 6, 7 powers. So multiply that by 3.1536 times 10 to the 7th power. That's how many miles we're talking about here. So when we take, we take 1.86 times 3.1536. You get 5.865696. And then here, by the way, the reason why I multiplied those two is that the commutative property can move around, shift around this multiplication so that you put the coefficients side by side. You multiply and get that. Then you put the powers of 10 side by side. Powers with the same base, you add the exponents. So 5 plus 7 is 10 to the 12th power. This is how many miles it is. And I'm just the kind of guy that likes to have some perspective on things. How many miles is that? Well, 3 tens would make it 5,000. 6 would make it 5 million. 9 would make it 5 billion. 12 would make it 5 trillion. It's 5.86 trillion miles. That's a long way. All right, let's move to number 57. Or is it 57? Yes, I want to talk about Avogadro's number. All right, so this is everything chemistry. I took that a long time ago as well, and you know what? I don't remember much from chemistry. But this is a helpful reminder about moles. The number of hydrogen atoms in a mole is Avogadro's number. 6.02 times 10 to the 23 power. That's a big number. We talked times 10 to the 12th was trillion. Bam! So if 1 mole of gas has a mass of 1.01 grams, estimate the mass of a hydrogen atom. So right away, we're probably thinking if there are almost infinite, like there's a huge number of these atoms in 1.01 gram, the mass, remember mass is usually measured in terms of grams. This is going to be a tiny, tiny, tiny number to talk about the mass of a hydrogen atoms if we're still using grams. So sometimes you just see a bunch of numbers and it's hard to figure out, it's hard to just get some perspective on it. So here's your perspective. The mole is the thing where all the atoms come together. So it's like, I've got, let's just pretend like this actually represents the mole. And it's 1.01 grams. They're asking what the mass of all those hydrogen atoms are, what each one individually would be. So in order to do that, the mole is just made up of this many hydrogen atoms. So it's like I just got to divide 1.01 grams per mole divided by 6.02 times 10 to the 23 hydrogen atoms per mole. We're trying to figure out what the gram is for these innumerable number of hydrogen atoms, which means all we got to do is flip the second and multiply. All right, so hopefully you guys can read that okay. It's 1.01 now grams, I'll just use G, per 1 mole times 1 mole, the moles cancel, over 6.02 times 10 to the 23 atoms. All right, so what the heck? What are we supposed to do here? Well, let's get some space over here. Yeah. So you got 1.01 divided by 6.02 times 10 to the 23rd. Now, here's the thing about dividing using scientific notation. I need to compare something up top with the power of 10 on the bottom. Right? So we need to ask ourselves, what is a way to create a power of 10 when there doesn't seem to be a power of 10 to begin with? Well, we could take it times 10 to the 0 power. I know, that's weird. But here's the thing. What is 10 to the 0 power? Maybe you guys don't remember this. It's been a while. 10 to the 0 is equal to 1. 1.01 times 1 is the same as 1.01 times 10 to the 0 power. That gives us all we need to do. Because now what we do is we divide these two numbers and we subtract the exponents for these two. 0 minus 23 is 10 to the negative 23 power, which makes sense because these atoms are tiny. Negative exponents, for scientific notation, moves the decimal place the opposite way. Not zeros of power, but 0.0. Point zeros. Lots of, this is like 0.0000000, dot, 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 dot. So then we can just figure out what the decimal is. For this, it's 0.167, I'll just round it to an 8. And then what your job is to kind of like put it in the final scientific notation is you say, I need to borrow a power of 10 from this part. So it's like, it's 1.68, and I need a power of 10 to make this a 1.68. So I'm just borrowing from this 10 to the negative 23rd. It's kind of like saying, hey, I've got a bank that owes $23 billion. Hey, now they owe $24 billion because they just gave me $1 billion to make mine work. And that's the weight of a hydrogen atom in terms of grams. It's pretty light. Well, shoot. Number 61 about tornado pressure, I'm just going to let that one slide. You know what I might do? I might work it out and then take a picture of it and just show it to you on Google Classroom. Because I want to keep these videos under 15 minutes. I've already given you almost 45 minutes worth of material. I feel like that's overwhelming if I make another video. So we'll leave it at this. Hopefully I'll see you guys on Monday. See ya.